Okay, here's a demonstration of my project. I'm going to go ahead and program what I have to the board. So we'll reset. All right. We've got the potentiometer. If I turn it, we go from about 0 to 495 with some smoothing or averaging. And then if I set the low end of the range here to about there, and we'll set the high end to about here. Now if we go below the low end, we turn red. If we go between the low and the high, we turn green. If we go above, we turn blue. And then I'll set it one more time just to verify that it works. So here's the new low end. Here's the new high end. Now if we go above that, we're blue. If we go between, green. If we go below, we are red. Okay, here is the Verilog and C code for my project. So first module is my 7-segment control module. Purpose of this is to take a clock input, a reset, and a binary number, which is what will be converted from the potentiometer, and then output to the 7-segment display. Um, it just uses some logic here to separate out the digits and configure the data and output it accordingly to the 7-segment display. Here's the patterns. And the next module I have is my range control. It also has a clock and reset, and then it takes in the current value of the potentiometer, and it takes a low button and a high button for the low and high end of the range, and then it outputs the current value, the stored low value, the stored high value. So the purpose of this module is just to detect the buttons and store the low and high value and pass them as outputs along with the current value. And then I have my top level module, which connects everything together. It's got a clock input, a reset, and then this is how I wired up according to the schematic um, to read the potentiometer. Then I've got the buttons, the 7-segment, and the outputs that will go into my IP module. And then it's also uses DRP to read the ADC, which has the potentiometer value. So here's the ADC wizard instance. Those are just some debug LEDs I had set up. Here's the 7-segment display. Here's the range control. And here's the auto-generated wrapper for my block design, which I'll show in just a minute. Then here's my constraints. I had some stuff in here that I didn't actually use because at first I was testing it out with just using the switches as a value, for example. Here's my block design. So I've got my top level module with all my Verilog, and then I've got my IP block. So here's all the inputs. Here's the outputs, the 7-segment display, and then from this module we go into the IP block, uh, which allows me to essentially take the current value of the potentiometer, the high value from the range control, and the low value from the range control, and read those in software, and then write code that controls the RGB LEDs accordingly. So I'll briefly go over my IP block code looks like. So I've got my inputs and outputs, just the current value, high value, low value, and the RGB R, G, and B. Same inputs and outputs. I edited some of the um, default AXI logic uh, so that it couldn't write to the first three slave registers anymore because those would just needed to be read only. The only ones that it needed to write to was the one that stores the RGB values. And so the first three um, just store the current value, the high value, the low value from those inputs. And then down here, um, this is where it uh, writes to the RGB based off the slave register. Finally, I pull up my C code. So I've just got the base address, the slave registers. Uh, we've got the current value, which I could have just put as the same as this address, but I just wrote it like this. We got the high value, the low value, and the control register. So four slave registers total. So I just wrote a simple loop that takes the current value, reads it from the register, same with the low value and the high value. And if the current is less than the low, we turn the RGB to red. If it's greater, then we turn it to blue. Otherwise, we just output green.